Okay. Good evening. Today, today we will be going through what is the experiment today? Finding the energy density of a liquid using a UT. This UT, right? Okay. So, what is the purpose of the experiment? To learn the principles and finding the relative density of a liquid using a UT. Now, here we are using a 112. Okay. Please again, I'll tell you what liquids can you use to find the residual density. Okay. So that is the purpose of the experiment. Then we have to go through materials, theory, procedure, before special purpose. Okay. Uh, Hi. What are materials and apparatus we use? A U-tube, two half-meter rulers, coconut oil, water, clamp stand, and a state square. Okay. අද කට්ටිය අඩුයි නැත්නම් දැන් රෙකෝඩින් එක නැති කරනවා ඕකේ තුමාලා කියන්නකෝ තුමාලා කට්ටිය අඩුයි නේ රෙකෝඩින් එක so yeah, so what is the theory we use here in a YouTube? The pressure at the same level in a continuous liquid is equal. Again, maybe continuous liquid, what do we use here? The water, continuous liquid. At the same level of this liquid, we have same pressure. Okay, so that's the theory we are going to be using here. So by using that, we can write two equations. For now, let's take the following interface. What is the pressure acting at A and pressure acting at B? Pressure at A. Pressure at A pressure at A is equals to atmospheric pressure and water. Same way, pressure at B is equals to Saturday දාන්න බලමු. ඕක දාන්න there students. What is the pressure at B? Pressure at B is equals to pressure at A. Why is the pressure? What is the pressure at B? Atmospheric pressure and coconut oil. Height pressure due to hydrostatic pressure due to coconut oil. Near. Then we can use those two. So first of all, let's take pressure, atmospheric pressure at 5. Okay. So 5 is going to be equals to, sorry, pressure at A, pressure at A is equals to pressure at B. Okay. Then we can write 5 plus H water, rho water, G is equals to H liquid, rho liquid, G plus 5. Okay, next. Then we can cancel off 5, G, and we are left with H water, rho water is equal to H liquid, rho liquid. To find relative density, what should be the gradient? To find relative density, what should be the gradient? liquid over water or liquid to find relative density. To find relative density, yes, for relative density equation is rho liquid over rho water. We are taking relative to water. Yes. Then rho liquid over rho water in the methane movement. Okay. Then rho water for later we have H water here, means liquid here. So using this we can write a y equals minus graph. Are you see with that? So relative density we can find here. Or in order to find density, we have to multiply by rho of water. Multiply gradient by rho of water. Okay. Mm, Another thing is the y equals minus graph. Where ultimately when you are drawing the baseline, you should get a plus C. As y equals minus graph it at my indoor. That is clear. Now, let's move on to procedure. What I mean, first of all, we have to attach the YouTube vertically to a clamp. First of all, we have to attach the YouTube vertically to a clamp stand. Then we have to connect 2.5 meter rulers on either side of the tubes. Yeah, either side or in the center. Only read but it should be closer. The reading should be closer to the tube. Okay, that is the only rule. But that's another rule to follow when we are making a when we are like fixing the meter ruler. What is it? When we are fixing the half-meter ruler, there's another rule. What is that rule? What is that rule? Done this. YouTube करना कौन सा करना? About the meter ruler. Okay, then maybe then what it done. Put three values. Zero of both the meter rulers, half-meter ruler should be at the same level. Okay, that is the only rule we have to follow. Zero of both the meter rulers should be at the same level compared to the YouTube. That is the only rule we have. Then there's also another thing in other class class now notice currently there. Okay. Why is the first to proceed to attach the YouTube vertically to a clamp tube and fix the 2 meter rulers? May first to may have procedure at the end. Normally when you go to a physics lab in your school, may occur set take make meter ruler occur set take but here our first two procedures are to make the actual apparatus itself. Why is that? If you check our handbook ke check karana, our materials are given as a YouTube, 2.5 meter rulers and clamp stand. YouTube apparatus still a So what they are expecting from that is, you have to actually make this apparatus in order to proceed with the experiment. You might handbook අපි ඉස්කෝලේ හරි කොයි හරි ප්‍රැක්ටිකල් එක කරනකොට they will give the entire setup to you and they will call it YouTube apparatus කියලා. එහෙම දෙයක් නෑ අපි ඉස්සෙල්ලා we have to make this apparatus. Okay. Then first of all you are pouring a dense liquid inside. Dense liquid කියන්නේ මොකක්ද? මෙතන we are using water and coconut oil. So dense liquid is water. The water dala. Then next step is we are going to put a small amount of coconut oil into the second arm. Okay? You're going to put small amount of coconut to the second arm and then small amount here. And then use the set square and then find the common interface, height of the liquid and height of the coconut oil. Okay, neither. So we can say this is this reading is X, this reading is Y, this reading is Z. So what is H water? H water is equals to H water is liquid. What is that? හරි H water is equal to මොකක්ද y minus x a y minus x its liquid is equal to z minus x okay නේද තේරෙන්නේ නැති කට්ටිය අර්ථ උසන්න බලමු මොන නිකන් ස්වැඩින් තේරෙනවා වගේ තේරෙන්නේ නැද්ද what are we doing this experiment for to find the relative density relative density හොයන්න පුළුවන් විදිය කොහොමද we can use the pressure and the pressure is at this common interface okay because the rule is according to hydrostatic pressure the pressure at the common interface will be equal on both sides. That is the pressure here we have calculated here. Okay, and then pressure at this point we have calculated here. Okay, neighbor. Then මේ equation එක එනවා මේ equation එක y equals mx graph එක එනවා. Okay නේ? You understood up to that point thing? Yeah. Okay. So after this make H water you need a height of the water and then height of the liquid. H water කියලා අපි ගත්තේ කාවද? Now this is what we take as H water. And here this is what we take as H liquid. Okay නේද? මේක මාක් කරන්න තමයි මේක වෙන්නේ. Because we are finding this H water over the is head pressure of this what you call water column. And then there head pressure of this oil column. Okay. Now in order to find H water, we take this reading using H square. To find H water, it should be y minus x, and then for H liquid, it should be z minus x. Okay. Did you understand? Okay. Now yeah, then you have to add more. Hurry. Then now we normally use something called a dropper. Hurry. Dropper එකේ oil ටිකක් අරගෙන මෙතන දානවා. Dropper එකේ දානකොට how much normally we can vary the liquid from 1 millimeter to 5 milliliter. So like 5 milliliter ගන්නවා නම් you take 5 milliliters of coconut oil and drop it into this tank. Okay, then what will happen when you drop it into that tank? Common interface පල්ලයට යනවා. Okay, common interface පල්ලයට යනවා. මෙයා චුට්ටක් උඩට යනවා. මෙයාට වැඩිම උඩට යනවා. Did you understand? common interface will drop by a certain amount. Okay, this level y will increase by a certain amount. Okay, z will increase by an amount that is greater than this amount. Okay, එහෙම okay, that is a let's say that is an external එහෙම okay, then what will happen? Its liquid is a bit greater. ඊට පස්සේ H water එක වෙනස් වෙනවා. So again we have to take the reading x, y, and z and mention it as the next report in the table. Table we have to take 5 reports. 5 නෙමෙයි 6 reports. 6 reports. Okay, we have to take 6 readings. And then using that 6 reading, H water H liquid හොයලා we have to plot a graph of H water versus H liquid. Okay නේද? There's one more thing. We have H liquid as independent variable. Okay. As for what we know, in a graph, X value should be evenly spaced. So what can we do? Then let's say we got it as 10 centimeters. හරිද? Okay. Using the dropper, we add little by little until it becomes 15 centimeters. Okay. We drop little by little to get 15 centimeters. Okay. Then after we get that, we know how much of the dropper we need to make it go up by 5 centimeters. Okay. Then next time you take a measurement, you take that amount, preset amount, and put it back in, and it will become 20. It is the high moment, then 25 and all. Even if state values contemporary, if you know the exact amount, amount of coconut oil, you have to drop it into that arm in order to get this evenly spaced, what do you call it? X-axis. Okay, Neil? I hope you understood that one. Next what is my next week time. Hi, that's it with the procedure. Do you have any doubts? Doubts නැති කට්ටිය, let's say put a heart reaction. Okay. Okay. Thanks. Then let's go to special points. Then අනිත් එකේ වගේ නැතුව මේකේ ගොඩාක් special points තියෙනවා. Because why? This is a small experiment with let's say huge variance. Make it all. You can make so many variations to this experiment. That's a lot of special points to remember. First of all, the higher density liquid must be poured first. Now, there's a point like this. So you in this U-tube, okay, that's one thing. We cannot pour mercury into this with coconut oil and find the relative density. Why? The relative density of mercury is really high, okay, compared to coconut oil. Anytime mercury here, density, relative density, then what can we do? There's a certain limit. There's a certain limit for the what do you call liquid you're going to use here in order to find the relative density. Now normally we add water here. So we normally add water to find the relative density, and its density is 1000 kilograms per cubic meter. No. we can use when we can find the relative density of liquid um, of liquids of relative density between 1250 and 750 value. Okay, 500 back, 700 50 query, 500 value even a back because when you have to let's say you have taken liquid with 500 density, 500 kilograms per cubic meter, making centimeters දෙකක් දැම්මම එයා එකක් එනවා. Okay, then you can't do the experiment. Why? මෙයා 5 centimeters move කරනකොට මෙයා මේ 5 centimeters move කරනකොට මෙයා 2.5 දැන් මාරු වෙන්නේ, there will be a lot of trouble. Okay, so let's say if you want water to actually move by like 5 centimeters, then මෙයාට 10 centimeters end on 10 centimeters 6 times 60 centimeters. The YouTube is not that long. Okay, nේද? So we normally take liquids of this range if you are finding their relative density. Okay, nේද? Did you get that point? Yes. Then here is 1000, it is 1000. Okay. So if you are using a liquid of density 750, what should we do? We first pour water into the U-tube up to like this level. Okay. Then we pour the liquid with 750 kilograms per cubic meter density into one arm to find the relative density of the liquid. ඒක normal වතුර දැම්මට පස්සේ liquid එක දානවා. Then using that you can change the vary the liquids what we call height and then plot this graph. What happens for liquids that are greater with density greater than water? ඒ වගේ කෙනෙක්ට මොනවද කරන්නේ? Okay, so let's say you have to find the relative density of a liquid where its density is somewhere around 1100. Okay, it's somewhere around 1100, but you don't know. Then first, which liquid do you add? Liquid නැත්නම් water. බලන්න liquid දාන්න නැත්නම් water දාන්න. Liquid's relative density 1100. Okay. එහෙනම් වතුර දාන්නවද? We don't put water. Okay. We first start with yes. We first put the liquid in. Why do we put the liquid in? Because if you put the water in main level then if you put the liquid will go to this point. What do you call this point? Go to the U junction and then separate the water into two liquids. Only ඊට පස්සේ එතන කරදරයක් වෙනවා. Right? You have water on both sides and liquid on both sides. So first of all, in this case, we put the liquid in. And then liquid එක දාලා then liquid එක දානොම you are left with water. You put a small amount of water and increase the amount of water. Water එක දාලා you are taking H liquid versus H water. And here independent variable is water. So මෙයාට gradient එක කොහොමද එන්නේ? මෙයාට gradient එක එන්නේ raw water over raw liquid කියලා. හරිද? මෙයාට මේ relative density. හරි මෙයාගේ අනිත් පැත්තට මේ relative density. Okay නේද? That is how you may find the relative density of a liquid that has a greater density than water. Okay? ඒක හරියට කියන්නේ අපි ඒකේ මේ practical book එකේ තියෙන්නේ you can find the density of liquids with the closer to water and the denser liquid should be put in first කියලා. හරි අපිට හැමදේම දෙන්නේ මේකනේ. මේක එකපාරට දුන්නා නම් අපිට තේරෙන්නේ නැහැ. The only statement they are given is you have to put the denser liquid in first. Then මේ වගේ එකක් දුන්නා නම් you put the liquid in first and then You vary the water independently, and depending on that, you find the liquid's density. Okay? Are you fine with that? Thumbs up if you are fine with that. Okay. The distance in liquid should be poured carefully so that it falls around the inner surface of the glass half and rests smoothly on top. Make the acting. You have put water in first. පණිවිඩ දාන්න වතුරනේ මේ පැත්තේ ඉන්නම. මේක අමතක කරලා මේ පැත්තේ ඉන්න. Okay? You have put water in first නේ. Water එක දාලා දෙන්න බලන්න. Now when you put coconut oil, හරිද? They have you can put it in two ways. Either, let's say this is the opening. Let's say this is the opening of the tube. Either you hold the dropper like this. Dropper like name either, or if this is the tube, you are holding the dropper like this. Let's call it A and B. Okay. Which method do you choose? A or B? B or B? Shall I tell you why? May drop කරන්න what will happen? May oil drops එක වැටෙන්නේ මේම. Okay, it doesn't touch any of the walls. එහෙම වැටෙනකොට it will there will be certain velocity කියන්නේ due to gravitational acceleration. ඒ gravitational acceleration එකේ මේකන වදිනකොට it will break into droplets and fall into the water as well. දැන් මෙතන ටිකක් contamination වෙනවා. හරිද? Then if you don't do it properly, මෙතන හරි line එකක් එන්නේ නැහැ. So what we do is we hold it along the wall, hold the dropper along the wall and let the oil flow along the wall. Then we don't have that problem of contamination due to falling droplets. Okay? That is one. Another thing about this experiment, a disadvantage of this experiment, can we use miscible objects here? So miscible liquids here? No, we cannot use miscible liquids here. Liquids must be immiscible. Okay? What else? Then you should replace water with an incredibly dense liquid. You should replace water with incredibly dense liquid. Okay? ඒකනේ මොකද්ද? mercury. තව තියෙනවා නෑ liquids නෑනේ. metal liquids. mercury දාන්න බෑ. Why? You are trying to compare 750 what do you call it? 750 kilograms per cubic meter with 13,600 kilograms per cubic meter. හරියයිද? Then to make a movement, you have to put 14 centimeters of liquid here in order to make it move by 1 centimeter. If you are taking 6 readings, you need 84 centimeters. And then we have to keep it within 15. We cannot go up to 50 as well. So that is there. Then 0 mark of both the vertical ruler scale must be aligned. If not, the experiment is completely wrong. To keep a maximum measurement error under 1%, to keep your measurement under 1% percentage error, the height of the liquid should be more than 10 centimeters. Normally, we are using a half meter ruler. So, 10 centimeters varying mainly and only, what do you call? Measurement should be greater than 10 centimeters in order to reduce the percentage error to less than 1%. Okay? We can't start with 10 centimeters, okay? You know, we have to start with 15. Okay? 10 centimeters in button. when you may drop some coconut oil, okay, into the liquid, okay, as soon as you let go of the dropper, yeah, look at body oscillation now. There will be small oscillation due to the sudden unbalanced force acting on it. In the body oscillation, you cannot take the reading while it is oscillating, okay? It should become steady. Make a common interface of these liquids and make a square with it, but there are some YouTube name Tino. Some are YouTube name Tino. Okay, that's a curve. Then the common interface point can't go below this point, okay? Make curved part together. May what you call common interface under. Okay, that is one more thing. What else? Are you clear up to this point? If you are clear up to this point, thumbs up එක දාන්න බලන්න. thumbs up මදි. තව දාන්න බලන්න. Okay. That's done. Now we have two more points. Yeah. When taking multiple radiations, okay, then you gonna what happens if you add water into this? Then what will happen if you put water into this? Simple. If you put water into this, what will happen? දාන්න බලන්න chat එකට. coding. Not only the height of the water column, height of water column, oil column, and the common interface. All three will increase. Height of oil column, water column, and common interface. All three will rise or increase at the same amounts. Again, with the common interface 1 cm මේ H water එකත් 1 cm වැඩි වෙනවා. H liquid එකත් 1 cm වැඩි වෙනවා. Okay? So if you have issues with taking readings, the easy way of doing it is you have to add some more water. We have taken 5 and 10 centimeters. And then circumference says 5 and 10 centimeters are not correct value, good value because your percentage is greater. Then what can you do? 10 centimeters water add karna. 10 centimeters water add karna. Okay? You have to change these values. Okay? You have to add 10 centimeters for each value. So now 15, now 20 minutes. And then you can continue with the rest of the experiment. 5 centimeters oil damage 25. And the very. න්‍යාය කිව්වේ හරිද අපි z value එක අඩුයි කියලා කියමුකෝ හරිද z and y values are lower හරිද එතන here taken like 10 minus 5 කියලා හරිද මේක මදි කියලා කිව්වා නම් what do you do you have to increase the measurement therefore when you put water 10 centimeters add වෙනවා නම් මෙයා add වෙන්නේ කීයද 20 and 15 කියලා. Okay, but still X liquid is same. Okay, X liquid will be 5 centimeters. Okay, neither. Neither. I hope everyone understood. Then next. last point, okay, we cannot use miscible liquids here. We cannot use miscible liquids here. Then you don't have a hair separators as well. They are okay. You if you want to measure two miscible liquid, no relative density of two what you call relative density of two miscible liquids, but if you don't have a hair separators, what procedure can we follow? Or what can we do? We take two YouTube, we take two YouTube, okay, and then connect each arm of one arm of each tube with a rubber tube. Okay, Nick? Then we pour one liquid to this side and the other liquid to this side. Okay, Nick? Okay, Nick? Then what do we get? Sorry. Then what do we get is we will get liquid pressures like this. We have liquid levels enough. Make the name I make a name. We have liquid levels enough. Okay. Here this will be H water. Okay. And then this will be H liquid. Okay. You have to find pressure at this point. Pressure at A and let's say it is at B. Okay. Pressure at A is equal to pressure at B. Why? These air pressures are interconnected by a rubber hose. So pressure at A is equal to pressure at B. Further, A1 we can write what is pressure at A equals to pressure at A is equals to pressure at C. Pressure at A is equals to pressure at C. C is only method. Okay. And pressure at B is equals to pressure at D. So pressure at B is equals to pressure at D. Okay. Then we can write PC by substitution. PC is equals to BD. Okay. What is the pressure here? 5 plus H water, raw water, D. Pressure here 5 plus H liquid, raw liquid, B. एक brain on here. Yeah. Then I open capital we get H water is equals to raw water or raw liquid times H liquid. Y equals image graph you can do the same thing and find the relative density of liquid. Do you have any doubts with that? If you have no doubts with that, put a heart reaction. Okay. So, shall we do 2003 paper? Mm, 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 mm. Yeah, here we go. We have 44 days left near. Take a more mix up than now. I'm only taking 1 hour. I'm taking 20 hours of 20 hours of 44 days. Take a look at the name. Okay? Maybe 20 minutes. 20 hours and 200 minutes. 200 minutes. Maybe 23 hours. Because 10 minutes, 10 minutes, because so I will be taking 23 hours. One full day from 44 days. Okay? That won't change your result. ये हम क्यों नहीं ये भी need to plan कराना एग्जाम के results um In order to find the density of coconut oil, you are provided with the following. YouTube mounted onto a vertical frame. Water and sufficient amount of liquid. Draw and table the diagram. Unna manga amathaku garpadi. No one didn't remember that way. Can you explain the last part again, assuming this? Hi, the story is in order to find miscible liquid. Okay? Past papers, if you do like 4 times, 4 or 5 times, 45, 50 enough. ඒක මාළුතු ගේමක් නෑ. Okay? That is past papers. Okay? Model papers නම් model papers එක you have to try and see. Okay? Model paper සමහර කට්ටිය 36 ගන්නවා වුණාට එයාට ඒ paper එක 45 46 ගන්නවා. So basically your idea is the idea is yeah, basically the idea is, can we relate any of these questions? Not enough. Our you have 45 days, 45 days at a day. If possible, I will send one of my papers, okay? Morning, one past paper. Evening, one past paper. Have no, morning one past paper, night one past paper, full paper. Now what I did was, I did papers for 7 hours. Do you have choices? If you have choices, you will be only doing for 5 hours. I trained for all 8 questions. So I did for 7 hours. Morning 7 hours, one full essay paper. Yes. Evening, one full night, one full essay paper. No. Then you will have much more, a bit more time, like 4 or 5 hours left. Let's say you are sleeping 8 hours. You are left with 16 hours. Okay. You are left with 2 hours. Unna calling money. Hari, mama me ඇත්ත කියන්නකෝ. ID my නෑ bio නම් okay මිනි මරන්න තමයි වෙන්නේ. You can't do 8 hours. Okay, 8 hours of sleep as per what I do. හරිද? Math students, as math students, our motive is to do as maximum questions as possible. Okay, I'm a math student. My motive is do as maximum question as possible in math, then you will get marks. That is the story. Okay, by game and you have to memorize. So what can we do? You take morning 2 hours, night 2 hours, and study bio. Revise bio. I'll ready for a okay, spending too much bio time in bio means you are losing marks for physics and chemistry. So morning 2 hours, night 2 hours, bio you are revising. Okay. Other than that, between that morning 2 hours and night 2 hours, you have a lot of time. एक ऐसे own papers करना, bio paper, physics paper, chemistry paper, own एका करना. Okay, that's how you bio students have to do. As per what I know from my friend. Okay. My friend did like that. මේක අවුලක් නැති වෙයි. මේව කරගෙන ගියත් මම මට මේක කරන්න බැරි වෙයි. I'll do this paper and then I'll answer your question. For the other student, are you still there? Yeah. මෙතන මොකක්ද වෙන්නේ? Pressure at A will be equals to pressure at B. That's true. Pressure at A is equals to pressure at B. Why is it? මෙතන තියෙන air pressure ටික සමානයි. So let's see, here we are feeling P pressure. එහෙනම් මෙතන we are feeling 3 pressure. Okay. A pressure at A and B are same. That is no, from the knowledge of air pressure. Here, using the knowledge of hydrostatics, we can say pressure at common interface is equal. Okay, nේද? Pressure at common interface is equal. හරිද? ඊට පස්සේ we have to say PA is equals to P, PB is equals to P, and the PA is equals to PB. හරිද? Whether PA is equals to PC because of our common interface theory. හරිද? PB is equals to PD because of the common interface theory as well. හරිද? ඒතොර එතන substitution කරලා ඒක එනවා. Then we get pi plus I A equation එකම ඇවිල්ලා I same graph එකම එනවා. Okay නේ? Fine නේද? Okay. Now let's go with the experiment. First of all, we have to draw the diagram. We have to draw the diagram exactly like this. Second thing, we are going to mark, label the diagram. YouTube, meter ruler, half meter ruler. Then half meter ruler mark करना water, liquid, coconut oil. Okay, then we have to mark those. What else? H liquid, the H water, H liquid. We have to mark those as well. ये ඔක්කොම mark කරානම් full marks. Yeah. If the densities of coconut oil and water are given by D1 and D2, find the expression. Current බලන්න. Next. Select the correct procedure out of the following in order to draw a graph in determining D1. Add more water, add more coconut oil. What do we do? We add more coconut oil. Give the correct reason for this. When you add liquid water, liquid interface, all the liquid interfaces go up by the same amount. Okay? That's so we add coconut oil into the arm. In such a graph, gradient is found to be 0.87. Determine the relative density of coconut oil. How? Determine the density of coconut oil. What is density of coconut oil is going to be? Gradient is equals to raw liquid over raw water. So raw liquid is equal to gradient times raw water. Okay? Then we have 870 kilograms per cubic meter. Fine. In this experiment, which liquid should be poured into the U-tube first? Which one? Water. What is the reason? If coconut oil will be divided into both arms of the tube if added first. Further, okay. If you want to determine the density of coconut oil with a fraction error of 0.1, what should be the minimum height pursued by the liquid? Clear? Fraction error. Fraction error of density of the then equation to that equation you have to enter the values and find the answer. Nothing much. Okay? Then when equation you have to enter the values into that equation and find the answer. So you get 2 centimeters. Okay? 2 centimeters. What is the experimental disadvantage of using mercury instead of water? What is it? fraction of percentage. Yeah, it has really high density. Therefore, for a small increment in mercury volume, mercury height, there should be a huge increment in the what you call coconut oil for the liquid use. So we can't use mercury. So that's it for today. Do you have any doubts? If if you don't have any doubts, heart reaction का दान बोलो. Done. Doubts नहीं. नहीं. Okay then. Yeah, that's it for today. So good night. I'll wind up the session.